Core system login in progress.
All right, so we need to build a new class based on scriptable object. Let me explain why. Don't type this, just listen. So in Unity, when you're working in the editor, this doesn't really affect production, but when you're working in the editor, if I have here, I don't know, string A, and it's equal to ABC. And down here, I declare string B is equal to DEF. If Unity serializes, string B is cast back to string A. So if I've set string B somewhere equal to something else, like GFH or whatever, XYZ, it doesn't matter. It'll be reset to the default value because it inherits from up here. System serializable does not fix this. This is just a Unity inheritance thing. And it only happens in the editor. So to avoid this, we use a script, what Unity calls a scriptable object. And that will make our life easier. Now, right now, our scriptable object-based class is not going to have any inherited children, but it will later on. And we would like to be able to work with those children in the editor. And because of that, we use scriptable object. That was kind of redundant, wasn't it? Okay. So, presets, material presets, we need to go to the material preset for each nugget. Like I said before, I can get the index of the submesh it's going to be on. All of our vectors, all of our vertices, our face indexes will be zero based, and they need to be incremented since we're combining them all together. Since we're taking all these different meshes, all these different mesh sizes, and we're combining them together. In combined mesh, Unity's combined mesh functionality will cause a glitch because of how many we're going to have. We need a way to constantly say this was the last index I used without doing a link query. What's our maximum index plus 1 over and over again. So that's what this is. Oh, well, this actually points to what index was used, where the vertex was placed. And this takes care of everything. XORG and ZORG is the origin of the X and Z origin of our chunk. That is the chunks column and chunks row, both times the nugget count. Very simple. Just don't want to set it over and over again. Or pass it over and over again. This should be set to the maximum size of a model, of the models you're going to use. And remember, this is just for a single side. So it's at least that times 6, excuse me. So it's not that limited. Right now, we're just going to set it to 2400. You know, if you're really looking at Minecraft, you can probably jump all the way down to 128 with no worries that you'll go over that. This evaluate is called from our main evaluate that we're about to write. we don't have nuggets yet. That is hilarious. A riot. Go above create results. So we're only working with one shape right now. Or actually two shapes, nothing and a cube. This is a preset of the material that will describe the materials used for each side. All the sides for me generally use 0. The top uses 1 and the bottom uses 2. Later on that gets a little bit more complicated. I keep getting told to slow down a little bit on scrolling away from this stuff. But I am including the code on GitHub. All right, back to our evaluate function. So we need all of our neighbors. Let's talk about that for a moment. Because this is where most people get worried. Sure, use Curta. So is a painter I have. So say 512 by 512. So I'm going to add no, not getting that little trigger there. All right, so I'm going to add to the vector layer. Let's see here, tool options. Don't want. Yeah, this was not the best choice here. But okay. So here's our nugget, our block right now, always square right now. This is the actual one we're working with. This is our neighbor 0. It's directly behind us. Here's our neighbor 1. Here's our neighbor 2, neighbor 3. Now the funniest thing about voxel versus hexagonal for me is that with hexagonal you only have 6 neighbors. But as you can clearly see here with voxel, you have 8 neighbors. So it's kind of comically more complicated. So this is neighbor 0, neighbor 1, as we've already talked about in the commons class. Neighbors 2, neighbor 3, neighbor 0, 1, 1, 2, 2, 3, and 3, 0. The neighbor above us is neighbor 4, and the neighbor below us is neighbor 5. But we can pull the whole layer in above us and the whole layer in below us if we want to. The way we look at these neighbors and use these neighbors are called opposites. What shape is opposite this side? Okay, so if there is a full chunk opposite side 0, then side 0 will not be shown. But we can set side 0 to have a side of our neighbor type of none. And then it'll always be shown in that case. That's why we actually have none. So our neighbor 0 If this is this is our side 0, and our neighbor 0 is a full chunk, then we will not draw anything. If it's a half chunk, then we'll draw half of it, depending on which half chunk this is, bottom or top. If it is if it's none, we'll draw the whole side, create the whole side. The reason we do this is shaders. Unity, if we had this finished right now, we could jump and look at it, and we are going to look at it shortly, but if you create a side that is fully covered, the Unity shader still calculates the lighting for it. Actually, Unreal still calculates the lighting, calculates occlusion, and that takes time and slows things down. It doesn't matter that you're omitting it by saying you can't see it. You're still calculating, and you will see in examples online where people have just given up because they will create every side of every block in their game, hexagonal, voxel, whatever. They'll create every side, even if it's fully covered, and then they don't understand why they get such bad frame rate. You know, they're on a i9, literally. One example I saw in Stack Overflow, the guy was on an i9, great graphics card, and he was getting under 30 FPS on this very small view, and he just declared the Unity sucked. It was Unity's fault. No, it's your fault because you're creating every single face out there. We're going to avoid that with our evaluate function. You know, I'm pulling off a Minecraft level frame rate on both my hexagonal and voxel at the same view range. Now, I know I'm not doing as much as Zoom right now, but I am pulling that off. And the major reason is opposites. And that is what I call them. Why can't I include you static? I spell you wrong. Well, you just ain't nice. Oh, I know. I made a joke about IntelliSense earlier. And it's punishing me now. Right now, we're only going to work with our major sides, though. We're not going to work with our subsides, our intercardinal sides. We're just going to work with our cardinal sides. So our south, west, north, east sides are our cardinal sides, and then our southwest, northwest, northeast, southeast are our intercardinal. So and we'll get to the intercardinals when we start doing tiling, because they're very important for tiling. Okay, we need to put our create sides in here. For Lab 0, we will be doing hard-coded create sides, which I love. I just love typing out these vertices.
Access granted.
Alrighty, let's take a... We are going to, as I said, create the sides manually. And And one time I did actually make this height based. Where each side will react in height based on the nuggets around it, but it became just crazy complicated for something that I would never use. What the? I personally think someone at Microsoft is anti-IntelliSense and is trying to break it to get rid of it or something. So I do like to wrap this stuff up in try-catches. That way Unity will take us directly to the error location when we double-click in the console window, and not just to the method or function. Let's just copy that method for our other 4 vertices. Makes it a little bit easier. This does really show us, though, how things work. So we're going to our evaluate results vertices array at our current V count, which will be we'll reset to 0 in our evaluate results. At the top, we're simply setting that vertice to that V count. This nugget can have up to, well, 2,400 vertices. Of course, we're not going to get anywhere near that. Actually, this nugget can have many more than 2,400 vertices. It can have 30,000 vertices. 2,400 is for our V count reference. And we are saying that we're putting this vertice in this vertice reference spot. That makes sense right down here when we do this. So although we're hard coding this, unashamedly, we're trying to keep our code as close as it's going to be when we jump over to Blender. And basically we're going to loop through the vertice, the indexes, face indexes that Blender gives us. And get where we stored each vertice, put it in there. We want to say this face group was used, face index group was used, so its material will be included. And our final submeshes. There we go. That will create a side 0. So we're setting the index equal to the vector reference index, which is always going to be equal to the V count, which is up to 30,000. For this face, our maximum face index is 3. So as we're looping through, we need to get the face index that was actually used versus this face index. So we're grabbing this index, 0, what you put in the 0 spot, which could be all the way up to 30,000, and that's our true face index. May seem like a lot, but when you try to use Unity's mesh combiner, you've had to create up to literally 1 million meshes, and it's just not going to work. So we're creating 1 mesh. Maybe we create all the way up to 3 meshes per chunk. That's not that bad. All right, let's change our normals here. First, everything will be on the X because this is side 1. So everything will be exactly on the X is 0. We'll start first of all up here in the front on our X's. I didn't really explain the X and Y up here. Our X is our left, Y is our bottom, Z is our back. So in this case, we're starting at the X going up 1, X going, or the Y going up 1, X going up, going over 1, and Y going up 1. And simply the X going over 1. Our UVs on these are full. So it would be 0, 0. The bottom left hand corner, we can use the same one. 0, 0 here. 0, 1, 1, 1, 1, 0. So we're actually looking at the side, not the top. And that will give us correct look that we're looking for. Everything else remains the same. So for our sides 0 through 3, we can actually pretty much just copy and paste easily. In this case, we're going forward on a norm. And all of our Z's will be on the front side. And our 2 X's, our first 2 X's will be over on the left side because you have to face it in your head. So our X's will be over on the side. And this really is a tutorial on why you don't do it this way. Because if you're trying to create 1,000 shapes, that's more than 6,000 sides. And right now we're just trying to create one shape with 6 sides. This was the best way I could try to persuade you not to do this. Was just to do one. Okay, now we're over on this side. So our first 2 X's will be, or our first 2 Z's will be at the back. All right, and the last 2 Z's will be at the front. All of our X's will be fully over. And we're going to point, the normal will point +1. Yeah, that's it. All right, let's create our top. Not too much different. So all of our Y's are up at the top. Actually, our first 2 X's will be flush with the left. The last 2 X's will be over on the side. All the Y's will be up at 1F in the C here. This C will be at the front, but this C will be at the back. I'm trying to look down on it while I'm doing this. And all of our Y normals will be 0, 1, 0. I guess you do have to go this way to get to where we're going, but you really don't want to release this in production unless you want to have a very limited game. Maybe that could be the title of your game, the most limited game. The worst clone of Minecraft ever. Alright, so all we're going to do, we're going to cheat on this one. And just flip our face indexes down below. Because this is really horrendous. Bam! Yay! Okay. Back to the evaluate. Now, imagine thinking about our opposites. Imagine having a different function method, a different create side for every shape, every side of every shape. So you're evaluating the neighbor's shape versus your shape, and then calling the correct method. That if statement or that switch statement alone is going to be around 20,000 lines of code. So you stick with that. I'm not. We want to provide multitude of shapes. Now, or be able to. Neighbor 0 will actually be the nugget itself. So it's really not neighbor. Let's talk about this real fast. We're sending in our offset, which we use everywhere. We have to, or all of our nuggets will either appear on top of each other, or we have to send in the offset for this chunk. We're going to our material presets. We're getting the preset for our nugget. And then I'm getting material 0 because all of my sides 0 through 3, the vertical sides are all using material 0. Okay, so there's those, but for 4, we're going to get material preset 1, and for 5, we'll get the material NS, not the material preset, but the material NS of 2. Let's get back up and build our actual chunk code, because our base shape is done for now.